Welcome to Pre-Calculus. Today we will investigate solving right triangles and finding measures of right triangles using angles of depression. We'll take a look at three examples. My first example, I have a right triangle where I've got some measurements indicated. I've got one angle, which is 48 degrees, and I've also got one side length, one of these legs is 92. And my instructions are to solve the right triangle. What it means when it says solve the right triangle is find all the side lengths and find all angle measures. So that's what we're up to. I need to find the two side lengths that are missing, and I also need to find the one angle measure that I do not know. In fact, I've got more than two pieces of information. I've got one angle, it's marked here as 48 degrees here at angle B. But I also know that the measure of angle C is going to be 90 from the corner marking. So for me to discover the angle measure of A, I need to just take the two measures that I know and subtract them from 180. So I'm going to take 180. Again, that's the sum of all three angles in any triangle on a plane, a flat surface. And I'll subtract 90 from it. That's going to leave me with 90. And then I'm going to take 90 and subtract 48 degrees. And that's going to give me 42 degrees. So just by subtracting, because I know one of the angles already, I can come up with the measure of angle A is 42 degrees. So that takes care of my angles. I've found all three angle measures. Now what I want to do is I want to find the lengths of the two sides that are missing. I'm going to label this side that I know with the length of 92 as B. It's opposite the vertex here at B. And remember, when we label that, it's with the lowercase for the side length measure. For the angle, we would label it with a capital B. So the pieces that I'm missing, if I've got B equals 92, I do not know side A's length. And I also do not know the length of the hypotenuse C. So what I want to do is set up a trigonometric ratio. Let's try to solve for side length A first. So I'm starting from 48 degrees here at angle B. The piece that I know is opposite of 48 degrees. And the piece that I'm looking for currently, the length of side A is going to be adjacent. And so when I think about which trigonometric identity would use these pieces opposite over adjacent, that's going to be my tangent ratio. So tangent of theta is defined as opposite over adjacent. So I'm going to set up specifically from angle B. So I don't have to use theta generally. I know its measure is 48 degrees. And then the length of the side opposite is 92. And I don't know the measure of A, so I'll just call it A. And I want to solve for A there. So currently I've got this measure A in the denominator. So I need to get it into a numerator position. So I multiply by A on the right side to cancel. And it shows up here on the left side to keep the balance. So at that point, I've got A times tangent of 48 degrees equals 92. At that point, to solve for A, I'm going to divide by tangent of 48. Remember, that's a value, that's a number. It'll cancel there on the left side and show up there underneath 92 in a fraction. And that's going to give me my missing side length A. So once I've got that, I just want to take 92 divided by tangent of 48. And I'm going to calculate that on Desmos. So we'll head over here to the graphing calculator. And we'll just plug that in. I do need to make sure, because I'm dealing with angle measures that are in degrees, that I switch Desmos to degrees. Once I've done that, I'm good to calculate. So again, I'm calculating 92 divided by tangent of 48. And I can find the tangent function under the keypad in the first tab of the functions, and it's here in the first column. So 92 divided by tangent of 48 degrees. And right away, that's giving me a side length of 82.84, 82.84. And we'll round to the nearest tenth since that's in our directions, 82.8. So we've found two of the side lengths. I want to then turn my attention to this last side length C. So again, I want to approach this using trigonometric ratios. And in truth, although we calculated 82.8 for the length of side A, I don't really want to involve that because that was an estimate. I had rounded that to the nearest tenth. So as I set up my next trigonometric ratio, I won't involve side A. I'm going to go back to side B because that's the one that's exact. It's given to me as 92. So I am looking for a ratio that involves the side opposite an angle and the hypotenuse, which is this side C. So if I, again, think in my mind what ratio sine, cosine, tangent would deal with the opposite side over the hypotenuse, that's going to be my sine ratio. And that's, again, that's the way we define sine, is the opposite side length from the angle measure divided by the hypotenuse. So we'll set it up again. I've got the angle, it's sine 48 degrees is going to equal, again, 92 divided by, in this case, C. So again, I want to solve for C there. The solution is going to be very similar. I'll start by canceling C to get it out of the denominator on the right. And it'll appear on the numerator level there on the left. So then what I've got is C times sine of 48 equals 92. And then to solve for C, I'm just going to divide both sides by the sine of 48 degrees. It'll cancel on the left. And we'll get our answer here from the right side. So really the only thing I'm changing is from tangent to sine. Let's see how that calculates. So again, I'll take it over to Desmos. Basically the same fraction, it's 92, but divided by sine of 48 degrees. And that's giving me a larger measure, which is good because this is the hypotenuse. It should have the longest length in the triangle. So that's going to be 123, if I round to the nearest tenth, 0.8, 123.8. We'll return to our notes to finalize. 123.8 is about the length of the hypotenuse. And with that last calculation, we have solved the right triangle. So again, what we're checking for when we say we've solved it is that I've got all three side measures. So I'm just going to highlight those in yellow there. And all three angle measures. So I have the 90, I had the original 48 degrees, and 42. We have solved the right triangle. Our second example only has two side lengths. So it's a different set of original information for us. We do also know that the angle here at C has a measure of 90 degrees. So the first thing I want to do is solve for that third side length, side BC, using the Pythagorean theorem. So if you've got two side lengths, a good way to set that up is with Pythagorean theorem. So I'm going to label these sides. If that's vertex A at the top of the triangle, the side opposite is side A. Vertex B is there on the right, so the side opposite it is side B. And then side C is going to be the hypotenuse. So as I set up Pythagorean theorem here to solve, a squared plus b squared equals c squared, I'm going to substitute the two values I know. I know that b has a length of 68 and c has the length of 96. And what I want to solve for is side A. So I'll highlight A there. That's the one I want to solve for. It's in a different color. It's in blue. So I'm going to start off. Let's subtract 68 squared from both sides. And that's going to give me A squared equals 96 squared minus 68 squared. And then to solve for A, I'm going to take the square root. And we'll plug that exactly into Desmos. I want to take and find the square root of 96 squared minus 68 squared. So we'll take that to the calculator to find the value. So it's the square root of, again, 96 squared minus 68 squared. And that's giving us an estimated value of about 67.8. We'll head back to our notes to finalize 67.8. That finishes finding all three of our side lengths, 67.8. So I'll write that in here. So I'm going to go ahead and highlight. We have solved for our side lengths. We got the hypotenuse, we have side A, and we had side B to begin with. So now we need to turn our attention to the two angles that are missing. So if I know that I've got the 90, what I need to do is pick one of these sides and one of the angles that I'm looking for. So without losing a lot of generality, I'm going to choose angle A there. So then what I want to do then is I want to use the two side lengths that were given to me exactly. I'm not really going to involve side A because that was an approximation. I rounded there. So the two that I have from side or from angle A, the sides that I have are going to be the adjacent side. So the side that is right next to angle A. So that's 68. And I also know the hypotenuse, 96. So as I search for one of these ratios that involves adjacent over hypotenuse, that's going to be cosine. That's how we define cosine at the outset. Cosine of an angle is equal to the adjacent side's length divided by the hypotenuse length. So we'll set that up. I'm going to leave the angle just as theta because that's what I'm trying to discover. I don't know that angle. So cosine of angle A, which is theta. In fact, what I'm going to do is let's call it A, just so I don't get turned around and think it's angle B, is equal to the adjacent side length 68 divided by 96, the hypotenuse length. So if I'm missing an angle, I'm trying to solve for it, and then it's involved in a trig ratio, I want to apply the inverse cosine to this left side. And what that will do is it's going to cancel the cosine function and give me A. Remember, the inverse cosine, really any inverse trigonometric function says if I don't know the angle, but I know the ratio, it tells me, given that ratio, what the angle would have been. And where we will actually calculate that is here on this right side, the cosine inverse of 68 over 96. So we'll get an estimate here. Solve for measure of angle A. In trigonometry, we do end up leaning on the calculator pretty heavily for the actual calculations. We do the setup geometrically using definitions, but then we really do use the calculator, especially for the trig ones. So I'm going to find under functions, I'm looking for inverse cosine. So I find it in that middle column under the trig tab. And I'm going to type in the fraction 68 divided by 96. And that's giving me an angle measure of 44.9 degrees, 44.9 degrees. We'll go ahead and mark that here. So we found angle A to be 44.9 degrees. Let me record it here in our answer. And then I'll write it in at angle A. That's 44.9 degrees. Now, there's two different ways we could go to find the missing angle at B. I could use the idea that it's going to be complementary to angle A. So I could just say 90 minus 44.9. That should be 45.1. That's just with the triangle angle sum theorem tells me all angles should add to 180. So that would add up to 180. We could confirm it using another trig ratio. So if I was going to do so, I would set it up from angle B and say that the opposite side divided by the hypotenuse, which is sine of B, equals 68 over 96. And real quickly to solve there, I'd apply inverse sine. And so just like we had done with angle A, we could calculate an estimate for angle B as inverse sine of that same fraction. So let's do that just to confirm that this should be 45.1. Inverse sine of 68 over 96. Let's grab the inverse sine function. That's at the top of the list in the middle of the column. And we'll type in 68 divided by 96. And that rounds to exactly what we were anticipating, 45.1 degrees. So the geometry is very consistent from the perspective of the trigonometric calculations. So we are seeing that that comes out to roughly 45.1 degrees. It's also consistent with the triangle angle sum theorem, which tells me that the angles in any triangle on the plane should add up to 180. And with that, we've solved this second right triangle. I found all three sides there in the highlighted in the yellow, all three angle measures highlighted in the green. Our last example is a word problem involving angles of depression. So we've looked at angles of elevation. Let's investigate this idea about angles of depression. So it's a word question. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, we want to find out what is the horizontal distance from the rescuers to this second person. I always draw a diagram to begin. So this is at sea. So we're going to put the ocean in there. And we've got a helicopter, our search and rescue team. And they are currently trying to rescue an individual in the water. So we'll place our first person there in the water. And the dimensions that we know is that this helicopter is vertically 18 feet above the water where they're trying to rescue the first person. There's the second person. So we'll place a second person out in the distance. So this person is farther away from the helicopter, also needs help. And so what the information we've got with relation to that second person in the helicopter is simply that the angle of depression. So what I'm going to do is I'm going to put a line that's parallel to the surface of the ocean. And then I'm also putting this line of sight between the helicopter and that person. And this angle that's created between the parallel and the line of sight, that is my angle of depression. And we're going to mark that as 42 degrees. Using the idea from geometry about alternate interior angles, if I think about these parallel lines being cut by a transversal, the thing that I want to do with an angle of depression is transfer it to its alternate interior pair. So if this is 42 degrees here, between the parallel line and the line of sight, this angle between the water and the line of sight is also 42 degrees. Again, because they're parallel lines cut by a transversal, these are alternate interior angles, and we know that those are congruent. So then what I'm trying to solve for is the horizontal distance from the rescuers to the second person. So it's really the distance between the two people who are being rescued. I'm going to call that X. So we are looking for X, that horizontal distance. Once I have this set up, it's really a similar question to what we've been doing solving right triangles. I have my angle, and I know that the piece opposite it is 18 feet. So I'm looking for a trigonometric ratio that involves opposite divided by, and then the piece that I have that I'm looking for, that horizontal distance, which I've labeled X, is adjacent. And the ratio that's opposite over adjacent is going to be tangent. So I've selected the ratio. Now I need to fill in the information I know. Tangent of 42 degrees is going to equal 18 feet divided by X. So we've seen this setup already in a few of our examples. I'm going to solve for X by multiplying to cancel it because it's in the denominator. It attains the numerator level there on the left. So then I've got X times tangent of 42 degrees equals 18 feet. And then to solve, I just need to divide by tangent of 42 degrees. That'll solve for X there on the left. And my actual value for that distance is going to be that ratio. 18 feet divided by tangent of 42. So again, we're going to lean on the calculator here. And let's get an estimate for the horizontal distance between the rescuers and the second person. Again, we'll set up our fraction. It's 18 feet divided by the tangent of 42 degrees. And that's, if I were to round, going to give us a distance of 20 feet. We'll head back to finalize that answer. X equals about 20 feet. And I can see that's my units because the only unit I had on that previous step was feet. Tangent 42 degrees is just a number. It's just a ratio. Well, thank you for joining for this investigation of solving right triangles and then using similar strategies to find dimensions of right triangles using angles of depression. Thank you for joining. See you soon.